So what I'm going to talk about in this second and final part of the basic Erlang section, I'm going to talk about how functions are defined, modules, which is where function definitions reside, and how we call functions from the shell. So we'll see those basic bits of Erlang functionality. Let's start off with looking at an example of a function definition. This is a function to calculate the area of a geometrical figure. And if you remember, a few slides ago, we talked about representing data. So we said that we would often use a tuple where the first atom in the tuple would say what sort of data we had. So for example here, we're saying a square of side 27 is represented by this sort of data. And a circle of radius 32 would be represented thus. So those are examples of the sort of data that feed in to a function like this. Now, let's have a look at what we see here. We've got a function whose definition consists of 4 clauses. The clauses themselves are separated by semicolons, and each clause represents a different case in the function definition of the function. The first clause, let's have a look at this, and the clauses themselves have 2 parts. Let's just establish the terminology. Each clause has a head, and those are the things that occur to the left of the arrow. And that the head consists of the name of the function applied to a pattern. You can see here in the first head, what we have is area applied to the pattern, square, which is an atom. Remember, square begins with a small letter, and side, which is a variable. And that variable will get bound in a way that we'll talk of presently. So those are the heads. So 4 different cases, each clause has a head, and corresponding to each of those heads, each clause is a body. And calculates the value of the function in that case. In the example that's circled here, there are 2 expressions. We first calculate the value of s, which is a local value, and then using that, we calculate the square root of s times s minus a, etc. And that's the return value when you calculate the area of a triangle whose sides are length a, b, and c. So you can see here what we've got is a function that calculates the area of a square, the area of a circle, area of a triangle, and the area of an other. Now what you see in the last clause is a single variable other, and that is the catch-all case which will return an error, because we're only thinking of the only geometrical objects we're interested in square, circles and triangles, so anything else is an invalid object. Now, just a bit of syntax about how these clauses and heads and bodies and so on are separated. Clauses are separated by using a semicolon. Within a particular body, the expressions making up the body are separated by a comma, and the whole function itself is terminated by a full stop. So just like the syntax of English, the full stop ends a whole sentence, whole function, and parts of the sentence are separated by semicolon, and within those parts use a comma to do a separation. So that's the general syntax of the function. In fact, how do we then call a function? Well, there are 2 ways of doing it. One is to write the name of the function, followed by its n arguments in parentheses. And that's the way you can call a function within its own module. But in general, the way you call a function that resides in a particular module is to write the name of the module, followed by a colon, and then the name of the function. Again, followed by the list of arguments. The module and function names here are atoms. One principle in Erlang is that module function names are always atoms. But one thing to be aware of is that a third thing is significant about a function. It lives in a module, it has a name, but also another thing that is significant is the arity of the function. So we can define a function foo of x. Foo of x returns x squared. But we could also define a function, same name, which has two arguments. And these are two quite different functions. This is a function foo of arity 1. This is the function foo of arity 2. So they have no relationship between the two. And if we want to talk about the arity, we say this is foo of arity 1, this is foo of arity 2, by writing a slash followed by a number, which is the arity. And of course the arity is the number of arguments it takes. Okay. So what we see on this slide is a generalization, the general form of a function definition. We have a series of clauses separated by semicolons. Each clause has a head where you see the function applied to a number of patterns, and the whole thing is terminated. Each body is a sequence of expressions, and the whole thing is terminated by a full stop. Now, when you apply a function, you pattern match on the clauses. But how do you do the pattern matching? Well, you do it in order in which the clauses are defined. So you first see, does the first clause match the arguments that I have? If it does, you evaluate the expressions in the body and return the result of the final expression. If it doesn't, you go on and see whether your arguments match the patterns in the second clause. And if not, you go to the third clause. When you're successful, the result you get is the result of the first matching clause. So a number of clauses might match, but you attempt them from the first case, and so it's the first one that matches, that works, that you use. On the other hand, it may be that none of them matches, in which case you'll get an error. So it's crucial to know that function clauses are matched in the order in which they're defined. Now let's have a look at a simple example of functions over numbers. What happens if we apply this to the arguments 2 and 2? We first look at the first clause, and what happens there is that we see, indeed, our two arguments are equal, so the result will be 3. Whereas if we apply it to 2 and 3, the first clause won't hold, and so we use the second clause, and we add the two arguments together to give us 5. Now, what happens if I write these in the opposite order? Well, in this case, we'll get the same result. But what happens in the case where we have the arguments 2 and 2? Well, 2 and 2 match A and B, so we'll get, in this case, the result 4. Moreover, we'll never hit that case there. So the order in which you write these things down affects the final result that you get. And it's usually the case that you put the most specific, nearly always the case, you put the most specific cases first. So you do the case where the two arguments are equal first, and then only the case where they're different second. The general case will be the case where they are different. Just returning to the example we saw a couple of slides ago, just looking at that, what happens if we apply that function to the tuple? You see here, if we apply it to the tuple circle 17. If we apply it to that, you'll see that the first clause won't. This does not match the pattern in the first clause, because what you have here is circle, and you need the atom square for it to match. But this will match the second, and what will happen is that 17 will be matched to the variable radius, And so the result we'll get will be 3.14 times 17 times 17. If we apply the function to rectangle 3, 4, that tuple, none of the first three clauses will apply, and so the final clause, this will always match, the variable other will match any argument, and what we'll get back is this tuple error, and so on. So that's what we get in that particular function example. Let's move on to another example, and here we've got the example of a factorial function. And what we do, you see again here, this pattern, that the first case is the more specific. So this first case only applies in the case that the argument is 0. We immediately get the result 1. In another case, so if we apply this to 3, the first case doesn't hold, so what will happen is that this n is matched to 3, and so the result we return is 3 times factorial 2. Now again, 2 isn't equal to 0, so we will again be in this case. Now, if you remember, we've talked about Erlang as having single assignment. We've assigned n to 3. What happens when we call factorial with 2? Well, each time you call a function, you get a new variable. It's a fresh n, and so what will happen now is that n will be assigned matched with 2, so we'll get here 2 times factorial of 1, and so on. That will become 1 times factorial of 0, so we'll finish up calculating the result 6, as you see on the slide. So that's an example of a recursive function, and we'll see later on that many of the functions we develop in Erlang are recursive, and that's one of the major control structures that replaces things like while loops and for loops, which we see we're familiar with in more imperative languages. Okay. So that's shown us how we define individual functions. Now what I want to talk about a bit is how those function definitions are put into files or modules. So Erlang modules have a .erl suffix, and it's expected that the name of the file and the name of the module are the same. And you find the name of the module in what's called a module directive inside the module itself. It usually comes at the start of the module. And the other directive that you see in every module is a list of functions which are exported from the module. And the function, if you want a function to be usable, to be called from outside the module, it must be exported. And the export list consists of, so in a typical module we'll have the name, let's say it's foo, and then we'll have an export list, which will be a list of, I suppose we've got a function foo fun of arity 1, function bar of arity 3, and so on. So we get a list in that directive of the names of the functions followed by their arity. And if a function isn't exported, then we can't use it. Now let's have a look at an example of this. We've got the module called demo. You can see its name is demo, and the function exported from there is the function double of arity 1. Just backing off so that it's not obscured. You can see in the lines that follow, anything that follows a percentage in a line in Erlang is comment. So you can put those on a line on their own, or indeed inside with some code to the left of them. And then what we've got are some function definitions as well. Definition of double and a definition of times. But note that only double is exported. Now what I'd like to do is show you how to use functions from within the Erl shell. Now we've seen that already. You type Erl in a Unix shell. We get shell prompts 1 greater than, 2 greater than, and so on. And what that does, the Erlang shell sits in the read-eval print loop. You type an Erlang expression followed by a full stop, and you get back the result. Now, the one thing we've not seen so far is what's called the compile directive, and that if we write C followed by the name of a file, name of a module, that will compile the module and load it into the shell. So let's take a look at that now. Let's take a look at, let's fire up the Erlang shell, and let's compile the demo file. And we get back the result, a tuple saying, OK, demo has been compiled and loaded. Now let's use the double function. Remember, we can call double, let's call it the 9. Oh dear, now what's happening here? We're getting an exception, we're getting an error, undefined shell command double. We exported double from demo, but of course what we've not done is we've not put the name of the module before the name of the function. So you can only call the function in the form module colon function. And there we get demo colon double, just as we expected. Good. And we could also call times. Demo colon times, remember, and full stop. But here we're getting another error. And the problem here is that we have not exported times. And so we're getting an undefined function error here. Undefined function. So that shows you how to compile and also how to call functions. Now, we didn't get undefined function here in line command 2. We got undefined shell command, because what the shell is thinking is that it's getting a command here, because the commands look like this. There's the compile command, and if you remember, we had the forget command and so on. So let's have a look a bit more about what Erlang shell commands there are and how we can use them. So here's a slide which is showing pretty much what I just showed in the shell, and here's a list of the common shell commands. Now, if you want to know what the shell commands are, one thing you can do is type help, followed by open and close parentheses. And remember, always the full stop. Among the commands you'll see listed there are H, which prints the history, that prints the last 20 commands, plus their results. The shell command B will show you all the variable bindings in force at that time. We saw the function f earlier on. F, when applied to a variable, will forget the binding of that variable. If you just type f, open close parens, on its own, that forgets all variable bindings. And finally, the E command will evaluate the nth command in the history, because the commands are numbered by the corresponding number in the prompt. And if you type -1, that gives you the previous command. -k gives you the kth previous command. And you can also use in the up and down arrow keys to scroll up and down the command history. Okay, let's take a look at some of those, an example of those now. Okay, so let's assign. Well, one thing we can do is we can scroll up, and using the arrow keys on there, we can create the command to assign demo colon double to 9. We've done that way, and we can also say, let's say b equals 37. So we've got two. Now, by asking for the bindings in force, we can see that both a and b are bound and their values. If we forget the binding to a and ask for the bindings in force, we can see that only b is bound now, and if we forget everything, we will see that nothing is still bound. If we ask to re-evaluate command 5, we get to see that that's 18, as indeed it was when we did it first time. If we evaluate command 6, you can see that that is indeed giving us the result 37. We can scroll back up, so we could scroll back up to demo double of 9 and get the result 18. So using scrolling, and as I say, we can scroll up and down, and then use the left and right arrow keys to
go through the line to edit as we might see fit. So we can assign C to 1 plus demo of double of 9 and get the result 19. And then if we look at the bindings in force, we see we've got A, B and C are bound. And I think the final thing to say is if we want to quit the Erlang shell, we issue the command Q. And you can see that has quit the shell. Now we'll conclude the basic Erlang section of this course, just reminding you what we've covered here. We've covered how to call a function, how to define a module containing a list of function definitions, how to write those function definitions, and also showing you how to compile those modules and access the functions in those modules in the Erlang shell. What we'll be doing next is looking at extending the way that we can define functions, particularly looking at recursion, and just getting Erlang to do some more complex tasks. And that's what we'll be doing next. Thanks very much.